Friends, we are going to learn the topic mean valued theorem. So statement of this mean valued theorem is if y is equal to f of x is a real valued function defined on a closed interval a comma b such that there are two things, f of x is a continuous over an closed interval a comma b, f of x is differentiable over open interval a comma b. So with these statements, then there exists at least one point C in between A and B, such that f dash of C is equal to f of B minus f of A whole divided by B minus A. So here one graph has plotted with the x axis and y axis. Here is one curve, y is equal to f of x. So on this curve there are 2 points A and B. A has value a comma f of a and b has values b comma f of b. On this curve there is one point C where we have drawn one tangent. There is a second which is parallel to the tangent. So this has a graphical significance and there are some intermediate points. There can be more intermediate points also. So slope of this chord we will calculate. So slope of this chord AB is equal to f of b minus f of a divided by b minus a. But since we know the formula f dash of c is equal to f of b minus f of a divided by b minus a, we get slope of the chord which is equal to f dash of c. Therefore, we have written here f dash of c equal to slope of the chord AB. Therefore, tangent to the curve y is equal to f of x at point C is parallel to the chord AB. So friends, in physical terms, the mean value theorem says that the average velocity of a moving object during an interval of time is equal to instantaneous velocity at some moment in the interval. So we are going to see one example. In this example, there is a car and this car is travelling 163 miles on a toll road with the speed limit of 70 miles per hour. So journey of 163 miles the car driver has crossed in 2 hours. At the end, on the toll road, the driver, that means the car driver, is issued a speeding ticket. The question is why? So why he has given a speeding ticket? So let us go for the solution of this example. So in this solution, as we know, since the car position is either continuous or differential, so in continuous on a closed interval and differentiable on a open interval, then there is no discontinuities on the graph. So the car has passed from one toll booth to another toll booth on the way, and there was no wormholes or teleporters to create the holes. Therefore, this mean value theorem applies here. So by mean value theorem, at one point the average velocity is instantaneous velocity. Therefore, the average velocity, we have the formula, velocity formula is total distance divided by total time, and the total distance is, here they have given in the problem statement, that is 163 miles. So 163 divided by total time is the car driver has covered in 2 hours. So 163 divided by 2, which is equal to 81.5. So car driver has crossed 81.5 miles per hour at least once in a while on the road while crossing road. So therefore, the car driver must have crossed the speed limit. The speed limit is given in the problem statement, that is 70 miles per hour. So at least once in a while the car driver must have crossed 81.5 miles per hour. Therefore, this car driver has issued the speeding ticket. So this is one of the example of the mean value theorem. So friends, in the second example of mean value theorem, this example is to check whether this Rolle's theorem is applicable or not for the function f of x equal to mod x and x belongs to the closed interval minus 3 comma 3. So for this problem statement, the task is to check the function is differentiable or not. So by the definition of differentiation, taking the left hand derivative, we get f dash of 0 is equal to limit h tends to 0 minus f of h minus f of 0 by h minus 0, which is equal to limit h tends to 0 minus mod of h by h. We know mod of h, why we have taken this, because f of x is mod of x, here is f of h, so it becomes mod of h. Now value of mod h is minus h, therefore this is minus h, h is as it is, so minus h by h is minus 1. So let us consider this as a equation 1. Now taking the right hand derivative, so taking the right hand derivative we get f dash of 0 is equal to limit h tends to 0 plus f of h minus f of 0 divided by h minus 0 is equal to, similarly f of h is mod h, so here we have written the same, limit h tends to 0 plus mod h by h. Value of mod h is h by h, which is equal to plus 1. Say this as a equation 2. So by equation 1 and 2 we get the left hand side, that is left hand derivative, which is not equal to the right hand derivative. Therefore this f of x is not a differentiable at 0. Thus the Rolle's theorem is not applicable for the function f of x equal to mod of x. So in the third example of mean value theorem, we are going to find the value of c in Lagrange's theorem for the function f of x equal to log of sin x, where this x belongs to the closed interval pi by 6 and 5 pi by 6. So for this example we will find the solution. So given equation is f of x equal to log of sin x, we have written. Now we have values of interval as a pi by 6 and 5 pi by 6, we will put one by one in this function. So first value is pi by 6, so f of pi by 6 is equal to log of sin, value of x is pi by 6, so sin pi by 6 is equal to, we know value of sin pi by 6 is 1 by 2, so this equation is equal to log of 1 by 2, which is equal to log of 1 by 2 is log of 2 inverse. This is equal to the minus log 2. So let us consider this as a equation 1. So similarly we will solve for the next interval value, that is 5 pi by 6. So let us put in the equation. So instead of f of x, x becomes now 5 pi by 6. So it is f of 5 pi by 6, which is equal to log of sin 5 pi by 6, and value of sin 5 by 6 is 1 by 2. So this is equal to log of 1 by 2, which is equal to the log of 2 inverse. Now this log of 2 inverse is minus log 2. So let us consider this as a equation 2. Now here let us calculate the first derivative of the given equation. So first derivative of the given equation, f of x is f dash of x, which is equal to derivative of log is 1 by sin x and derivative of sin x is cos x. Therefore the cos x by sin x is cot x, therefore the f dash of x becomes cot x. Now by mean value theorem, we have learned earlier the mean value theorem. The mean value theorem was f dash of c, which is equal to f dash of b minus f dash of a divided by b minus a. So by the same theorem, let us put the equation here, f dash of c is equal to f dash of our values of b and a are here. So value of b is 5 pi by 6 and value of a is pi by 6. So we are putting it f dash of 5 pi by 6 minus f pi by 6 divided by 5 pi by 6 minus pi by 6. This is b minus a, which is equal to, now we have calculated the values of function 5 pi by 6 and function pi by 6 earlier. This is in equation 1 and 2. So from equation 2 we get the first value, that is minus log 2, and the second value is also minus log 2. So this minus minus becomes plus, so therefore we have written here plus log 2, and here the 5 pi by 6 minus pi by 6 will become the 4 pi by 6. So here this minus log 2 and plus log 2 will get cancelled. So it is 0 by 4 pi by 6 will become 0. So we got the equation f dash of c as a 0. Now we know the f dash of c, here we have written f dash of x is cot x. So by mean value theorem, this f dash of c becomes cot c, and this is equal to 0 because we have earlier calculated. So this cot c is 0, therefore c becomes pi by 2.